exit.
The reference we have here.
Check the wrong one.
Okay. Okay, I think we are ready. Just give me 10-15 minutes to introduce company Swissma.
Check the wrong thing. The online will be presenter view. Hold on 1 second.
Sorry.
Sorry, 1 second.
Okay, sorry. Okay, this is Swissma, our factories and our office. We are based in Charlotte, section 15. Feel free to drop by for factory visits anytime, give us a call. So as a company, for those who doesn't know who we are, we provide total solutions. For roofing and cladding, we provide design of roof systems. We are also manufacturers, so we are factory, and we can also do installations. We take on contracts for certain projects as NSC, or sometimes as a communicated platform. So we can be a one-stop center. So to design the roof systems, normally we will have to understand your project needs, for example, your thermal insulation requirements, your acoustic STC values. All these are softwares that we have in hand that will assist us to design the roof system. Gutter downpipe sizing, we also use software. So if you have a need for this assistance, you can always contact us. Shop drawings, and to me, it is very key to have a proper roof system constructed. We do provide shop drawings. Any project that comes to us, we can assist. So without proper shop drawings, it's difficult to get quality work at the site. So these are just examples of shop drawings. So after capturing all your design needs, we will come out with a roof system scale, be it factories or whatever, or residential. So there's one distinction between us and the other manufacturers, that we provide a wide range of material choices. We have non-ferrous material as well. So we do have, like you see, color-on steel within color, that's from Bristol. We can also cater to pure titanium, zinc, copper, stainless steel, aluminum, and we also do membrane roof. So for coated steel, we have this strategy partnership with NS Rusco, and that's why the two of us are here today. So we sell all Rusco materials in coated steel. So these are our market segments. In short, any metal roof applications, you can call us. These are the product range that we carry. This is a Swissma architectural series. In here, we have many profiles like double weld stainless steel, wrinkle weld, snap weld, zip weld, cassettes, cladding, dark metal tiles, the membrane, and we also have the Swissma Anko series. So that's really one whole range of products, and on top of that, later on I'll share the sample series. So I did briefly introduce our, let's say, our signature profile, our Swissma double weld stainless steel. So this is a roof that is the most versatile to cover any roof shapes and can be three-dimensional. And we have concealed sliding joists that can allow for thermal expansion. And it's completely proof, as you can see, that is folded, right? Seam, tightly seamed. And just to give you images of what you can do, you can see that these are the kind of shapes that would require not only this can do, you require stainless steel to do all this. That can be curved and tapered. So this is the Sanko roof series. battery. Sorry for that, the battery getting went flat. So you can see we have a host of another profile, range of profiles of sample series. I will not go through every single profile just to share a few. So these are projects with done recently, especially in the finance side. So these are your recent foreign direct investment using our sample C block profiles and pre-tag for ancillary building for most of them. So your Boston Scientific Analog Devices, Venture Electronics, Ferrotech, Robert Bosch recently officially opened. Action Hanger down Sapam and Ferroa, and Honda Assembly Plant down in the central. Then again, we have this FM approved roof system using our Sysma sample SK32, which is FM approved. So projects using this profile like Micron, Osram, Infineon, Intel, Darlington, all these are in progress. And the biggest one is First Solar. I think it's more than 1 million square feet supply in First Solar using this kind of membrane roof system. So lastly, I'll just show this and show you some of the projects that we have done. This is our one of the first project under Sysma, which is the primary Southeast residence, and residence is in titanium zinc, is in our metal parts called Sysma metal parts format. This is the home ground here, Finance Swing Club. On the way to Tanjung Bunga, you see this titanium zinc swap. Then we have Devan Perdana in KL, titanium zinc. Rubber bundle, a very interesting design. You see, you can do very organic shapes. This is a stainless steel roof and cladding that we have done. This is in stainless steel for auditorium. This is a pre-patented copper in Perak, the Sultan Aslan Shah Gallery. This is Alamanda Shopping Center in Putrajaya, which is PDF coated aluminum in our Trouble Sensing. MRT station, those are the latest addition. This is a membrane room that we did in IKEA Chera using SKV as a liner. This is all the color stuff. Moving forward, this is very vibrant color building down smack in the middle of the town in KL. There's a lot of foods available there. Yeah, these food taverns. This is the airport using colourbound steel in our static steel, Toroga. KK Airport. Okay, this is the international school as well. This is Suchi International School. So this is what we call this sales gallery, but it's very interesting design, especially the color combination in our double well using Bruce Beaumont steel. This is a net housing. We do a lot of net housing in KL. Central area, this is an example of barn house design. Very typical down in Klang Valley now. So these are all the barn house net housing that we're doing and still ongoing. This last two slides is the project design build project that we do. We do the design and we construct it as a domesticated subcontractor to a label. So what you see are those carbon panels which we fix over membrane roof, membrane roof. So it's customized to meet the thermal and acoustic value because this is convention center as well. So this is how it's like, right? All the lines you see are just yet what we see is an architectural scheme for aesthetic reasons. The roof properly is underneath, which is a membrane roof. So with that, thank you for your attention. And now I will pass the mic and the floor to Jack for his presentation. Thank you.
Hey, good morning, everyone. Good to come back again. Relax. Okay. Just I think 2 months ago, I was here for another session with a panel contractor. So today, actually, I want to share about the steel extrusion because I'm an expert in this our material. So today, my topic will be covering 3 parts. The first one is intro of the steel usage for those roofing and wall applications. Second part will be those optimal criteria of steel that you should be aware of. Third part is always my favorite case studies because I love to go back to the whole project site to visit them, to learn what I think that we would continue to do it better and what the things that we should avoid it so that you don't face the kind of an issue in your future projects. Okay, first, introductions. The photo that you see currently on my right, on my left, is a typical finishes of the steel that used as the roofing sheet. I'm sure from here you can see that this part, something like silver color. Is that a color group? I said no. Actually, it's a bare finish or the laminate stem as an painted finish. Some people call them as galvanized steel. Some people call them as zinc-coated steel, or some of them call them as aluminum steel. So those are actually bare finishes. On my left here, extrusion, you can see the blue color. So these are termed as pre-painted coated steel with a color finish. And people always ask me, Jack, how you produce this product? Is it produced in Malaysia? I said, yeah, it's produced in Malaysia. Our plant is in Kama, Selangor, and we are always welcome if you want to visit our plant to understand more in depth about how the steel is being produced. First of all, of course, the coil that we use to do the galvanizing must be a cold coil. Those are light-ish sheets. After we go through this process, called as the continuous coil coating process, we coat the metal alloy. Metal alloy that we use in our copper plant is aluminum zinc metal alloy. Not so typical GI or zinc-coated. Yeah, it's aluminum zinc content for the modern method. After we produce the bare finish coil, from here you can see, right? What if client or you yourself, I want to have the white color roof. Okay, so what we put the coil inside our coil coating line to apply a layer of paint, yeah, on the substrate itself. Afterwards, what it becomes a pre-painted steel ring or coil. Then we will actually send this over to our customers. In this case, it's a right? They are going to roll from this kind of color coil sheets into whatever shape or profile that you choose from their catalog based on the requirement. Then from here, the roll sheet will supply to the project site for end-to-end installation. So it's a very simple way to check how a flat sheet become galvanized, then painted, and then roll form and supply to the project site. Next, this will be the very simple information about painted coil and also pre-painted finish coil. In Malaysia itself, we have a lot of standards to govern this type of steel. Likewise, for the pre-painted steel as well, we can see to be all the typical standards. And let's bear in mind, one of the point of the highlight is BMT itself is very, very key. It's only up to 1.2 mm maximum. What is the lowest we can do? It's only 0.2, the lowest. Why we cover this average from 0.2 to 1.2? Because of different usages. We are not only supplying for metal roofing usage. From this slide itself, we can see that there are a lot of applications, right? For roofing and welding classes, we even can supply this type of battery for you to do cactus sanitary panels. And also the lowest. Some applications they only require very deep material like 0.2 or 0.23 and 0.4. So this is the reason why we produce from 0.2 up to 1.2 BMT. Of course, why are we mentioning BMT? Because a lot of architect consultants they are not so sure about the terminology used by us or even used in the vendors. So from this you can see that this image is how we hold a piece of steel, which is really thin, right? And if I cut across this number, put them under the microscope to see position of it, you can see a multi-layer that actually cover the base steel. From here, you can see the base steel, top and bottom. Actually, here is a metallic alloy thin layer. If you use aluminum zinc other layer, aluminum zinc. If you use the zinc layer, only the zinc layer. And afterwards, you have the top and bottom painted finishes. In this image, you can see actually the blue color, right? Here, it's a blue color. So from here, of course, terminology about differences. The base steel we term it as a base metal thicknesses or base steel thicknesses. It's the thickness of the cold coil. Other time people do the galvanizing. That one is the actual BMT. After we do the galvanizing treatment, it becomes a TCT. Why? Because we need to add on a layer of the molten metal, other layers, top and bottom together to measure as a TCT. Then, if let's say it is the pre-printed solutions, we need to add on the color or the print thicknesses as well. Add on everything up, it becomes a after printed thicknesses APT. So this is how we define these three types of thicknesses: BMT, TCT, and also APT. In your step, when you want to run another step, you can do. Don't miss out the BMT. Jack, thanks for doing the interview. May I know how big is the coating layer? I put up here 3 images for you. Anyone want to measure from that? What is the thickness or micron for an A4 paper? Anyone want to guess? No worry. It's about 90 micron, 90 micron, means that 0.09. What is the thickness of typical human hair? Can you guess? I will guess almost 75 micron. Okay, this is not like me, could by the source on the bottom. Okay, anything incorrect, put by the source will come to me. But when calculated the search, this come from me. It's actually around less than 30 micron. Okay, it's a very thin layer. If we didn't do it properly, failure can happen easily. Because the glass was so thin. Let's say what if the sheet go to the side, the installer or the paper over the side doesn't carefully handle the product, have a big stretch, for example, then the product of course will be massively. This coating layer is very key. Okay, now the next slide is that how are we going to determine what is the micron for the metal alloy thicknesses of the layer itself? This one, first of all, you ask yourself, what is part of the coating that you put? Is it a GI of zinc coated? Is it a aluminum zinc coated? So from this, we can already ask the next question that what is the current spec for the coating clusters? So from this table, you can see this will be all the coating clusters. Yeah? From the GI step 100 until Z 600. Then for the gazettement itself, it starts from gazettement 50 to gazettement 200. If you know the material is set in, say example, gazettement 50, then we can tell that it probably gives you about 50 micron, 0.05. Please also find the reason why sometimes you get it to be 0.42 mmBMT / 0.47 TCD. It's very common use. But this is not with the two cases. What if it's not a gazettement 50? Then your TCD value will be different already. Because the number here will be different. Yeah, it's fine. Different. Some engineer ask me, Jack, how come this 0.42 become a 0.48 TCD? Then I check the step 4. Because of 200. 200 here, 0.06. 0.42 at 0.06 get from 0.48, which is correct. Now this is the simple things for all of you. I want to get an answer from you. The top here actually is a library that we developed, and storage in the website is to ease understanding what is the differences that you're actually getting. Okay. For example, if the silicon steel is the 1D, and then we know the formula. Basically means the BMT plus the other differences. Let's say in the case of 150, formula in itself, it will tell you is 0.05, right? If I add on 0.42 BMT, you're going to get a 0.47 TCD. ABT. If I do the measurement on the side, this is what you get. Okay. What if you measure it, you get 0.47, then you roughly get to the decrease on that, okay, it will be 1.2 and this is how to do the back calculation as well. Yeah. So all these things you don't run away. If someone will cheat you, just use my computer and measure. You can calculate. A 3-meter seal with a color layer. So from here you can see a layer of pin, right? This one, you need to refer to the supplier catalog or data sheets. Inside the document itself, they will tell you what is the pin thickness that they apply on either the top layer or the bottom layer. In this diagram, you can see the total top is about 25, total bottom is about 10. 25, 10. 20 plus 5 becomes 25. 5 plus 5 becomes 10 on the bottom. So total is actually 25 micron on both top and bottom layer. Go back to this diagram. And also the example, if I want to measure the millimeter scale on the side, what should I get? Yeah. Example is let's say it's a 0.42 mm again, color one SMRT steel. I know that 0.42 will give me 0.47 DCD is the power envelope. Then if I add on the thin layer of color one steel based on the data sheet itself. Okay, based on this information, I should be able to get 0.50 mm ABT on the side measurement. This is what I will get. Yes. As I mentioned, everything all this is accounted for. I will not run the one. But we can do any measurement easily with the micrometer. Then, why we need to study all these things? The answer is very simple. BMT is important because it gives you the strength of the material itself. If your BMT is not enough, you're going to get all this problem on the side. Okay, example. Fastener, when the installer or roofer the installation, easily get the rib. The worst thing is that what is now wall on the roofing sheet, it actually crack. This one. This school actually is a long term project that I visited in Brunei at the time. The 219 at the time. I went over to this mental scheme, just our housing scheme in Malaysia, the Prima house, old housing scheme. In Brunei, they're using all carbon steel over there because they are rich one, pay everything. But unfortunately, the reason they are using the BMT is only 0.35 BMT. So thin. Reason why I can get this photo because I want to do study, understand my carbon steel behavior and performance. I didn't dare to step up on the road because I asked then why the pad I use all the pad 0.35. I better not step on because if I step on, more crack may happen. If someone heavier than me, I get the wrong, right? It's easy, it's true. We use the ladder, over there, climb up the ladder, the motor goes up. Everything like this way. Yeah. Some is cracked, some is centered. And this is actually formulation. Very simple, you need to side over here. If you go there and you see, if someone who do maintenance of the little icon, if your dead skin is very thin, easily dented, like this one. Dented easily. Because of BMT is not enough. Then the next question comes. What should be the BMT that need to study minimally? What should be the minimum? It's very simple. I always go back to standard. Standard always provide me a guideline for me to refer to. Here is the standard that I extract from the reading code in Australia. So in Australia, reading code, they mention very clearly what type of profile, what type of BMT that you should have. Example, a chromometer profile over here. Okay, so they mention chromometer profile. You need to use minimum 0.4 BMT. For a conservative profile, like this one, you need to use 0.48 BMT. Yeah. So it's what the reading code in Australia covers. Malaysia, remember that code. It's like something of the you yourself and also the roofing supplier to discuss what should be my BMT. That's the for the project. Then another study in Australia, this is actually for cruel shapes. You can clearly what is the minimum BMT for roofing? On here, you can see 0.42 minimum. What if
the product is meant for wall cladding. What will be the minimum requirement? Inside here you can see 0.35. So from here, it helps us to do some so-called decision making much more easier. 0.35 should be the wall. 0.42 minimum should be the roofing. Right? Coming to Malaysia, the information we can look. We will have some so-called code from JCAL. JCAL is self-demonstrated for any metal roofing usages. Minimum BMT shall be 0.12. In this case, it's a concealed fixed profile. So you can see that it's the minimum 0.42 BMT. Why you consider it 0.47? Because of this magic number. It's only after financially. They don't give us about 0.05 other layer. But on 2 base, 0.05 other layer becomes 0.70. Of course, you want to improve the step of doing the APT as well. Because this one actually is a pre-the product. Actually, have the APT as well. Another profile mentioned in the digital spec is the PS15 using the screw one. Also mentioned in 0.42 BMT. So Malaysia will do that, but it was only for JL documents. In the private sector, we don't feel anything to come. Okay, so just be careful. If someone comes to you, propose you something very keen, think twice again. Yeah. So conclusion is that roofing sheets shall be minimum 0.42 BMT. Wall cladding, because it's not being compared to the traffic, we will wall on here or there. Then you use a thinner, 0.35, should be able to do the job already. Okay, of course, in the acoustic industry itself, a lot of manufacturers started to cut their ID on the quality how to create the product first. So from the number, we are able to check the product name, also made by who are the manufacturer. In this case, the product is called carbon steel, made by who, we might do so. And this is also an example, just not that one is before you install in the bundle shape, the bundle of the roofing sheets. This is after you install, you still should be able to see on the surface. Yeah. Why is it important? Because what if you set in carbon steel, right on the side, you should receive carbon steel, right? What if you flip over, it's another person brand or product name, or the worst part is don't have any name, nothing. Then just put the thumb down, up to the right again. Can you show me the group? Is it a carbon steel? Okay, now come to the technical part. I'm going to share 3 important information. First one is talking about the corrosion performance. Second is about the paint durability. And third part is the latest uniform by-law about the fire. Okay, first, acoustic definition is multi-layer, multi-coated steel, right? Performance perspective, we have two things that with the conclusion. First is corrosion protection, second is the paint. Well, come to the first part first, the corrosion itself. This is the barrier actually extract from the strength standard, whereby you mentioned clearly what are metal water alloy you can use or other type you can use. Short summary is that they actually two group. First group is called as the zinc-rich family, means that more zinc content than any other alloy elements. Second group is we term them as aluminum-rich family, means that more aluminum content matter than other. Yeah. So from here you can see the diagram of some structure. This structure itself is only one phase with the zinc outer layer. Bottom here is a type AZ or aluminum zinc coated. You can see the two-phase structure inside the microscope. So we can't differentiate the type C and so the type AZ. Of course, people ask, which type of coated class or coating type will give you better performances or durability? Okay. Now, I have a very simple example. I use the type Z or CSU with a coating class of Z275, meaning 175 grams per square. If I want to source, I remove or reduce some coating outer layer, make it a bit thinner. Let's say I use Z180, okay, from 275 to 180. The other layer is already thinner. Performance against corrosion protection will be also impacted. Because you can see a very fast corrosion sign pattern on the pattern.
past have been lower now. From 275 become 100 gram. Yeah. What if I change the number to use the type-based technology or the latent song contact as single seal, for example? So this one is using the 8 in class. So for me, even though the relevant rate is much more lower than the single seal sample, it's still able to outperform the GI sample, which is actually much more thicker. Reason why it's very different. Because the type-based technology is not more superior than the type set. That's why from this image, you cannot see anything happen on the sample. And this is to showcase to you that what are the mechanisms that the algorithm is able to use to forget the state of corrosion. From here, you can see that the GI sample itself, once it's in other layer, already consumed one off. What left over actually the residual that exposed to the atmosphere. And this is the thing that will cause the product to corrode easily. But for the type itself, the type share will be there are two top alloy inside there. You got aluminum, you got zinc inside there. So the zinc alloy layer inside the type also one off consumed. But what left for balance is the aluminum alloy layer that actually helps to slow down the corrosion activity. That's why you will not see any differential rusting happen on the time material as opposed to the type set material. Of course, the performance of the steel will vary depending on locations where you supply the material. Here I go out to simple diagram. Yeah, with the ISO 923 corrosion category. C2 means much more than 9, very normal, far away from the seaside, far away from the so-called industrial area. This one usually maybe 3 or 4 km away. Yeah. As compared to the C4 category, which actually higher consumption rate. And most of the time, the C4 actually means natural city. From this diagram, you can see the sample water exposed to natural city. So we call the category of C5. Higher number means higher possibility. So from those results, we actually feel fortunate. Why? Because all our senior they actually exposed all the samples throughout different location sites. This is the reason why we are able to plot from a different distance and the sample exposed. So from this diagram, we can do something that anything that more than 1 kilometer away from the sea, the corrosion activity actually quite substantial. Okay, as much to less than 1 kilometer. Anything less than 1 kilometer, you can see corrosion activity is very high. That's why, just be careful. If someone comes to you, offer 10 warranty years from the 9 and also the C5, it's not the true case. Because you all know, yeah, the C5 the corrosion activity will be higher. The lifetime will be further reduced. There's no way for to get the same volunteers from this location compared to this location. Because we all know this is data, we can tell everything. And this is a 20 years exposure sample that we will get from Australia. We can see that the still after 20 years is still perform very limited corrosion activity as compared to the GI field. Here we put a sample of GI Z275. And also another thing rich family called compound ZA275. Yeah. So all this rich family can able to perform as compared to the other rich family like single steel in this case. Okay, come to repeater steel. Just like all painted no colors. Same thing happens. This is all typically pre-painted galvanized steel or PTGI the mechanisms. This only exposed after 3 years old. You can see the surface already got a lot of corrosion activity. The paint color resistant. Some may also can get nothing happen. If we expose the sample a bit longer, this one is about 9 years old, also can get corrosion effect. And this is our product material galvanized steel. After the similar power division 9 years old, no activity was happened. No corrosion effect whatsoever on the galvanized steel sample after 9 years. As opposed to the UBBL Z275. And what if I put the sample inside the industrial area? Just now is the C type. Now at the industrial area, same thing. Single steel after 20 years is still performing. No corrosion activity. As compared to the GI. Okay, admitted heavy rusting. Only after 3 years. Compared to a pre-printed product, of course, paint layer will help to slow down the corrosion activity. But it will still rust. Why? Because what the zinc layer wants to consume, runs the PV. And the easier part to check with the carriages, because carriages, they are the first one to corrode first. These are our sample, nothing happened, no corrosion activity. And how can we assess or estimate what the lifespan of the implant? Currently, they don't have any one fixed number, like 50 years or 100 years. They only put 125 years old. For example, in a rural area, overnight, 5 on the seaside, typical GI itself, the lifespan is about 14 years. Then for the high AZ or losing doctor, the lifespan will be about 125 years. If I change the environment, let's say to a study closer to big industrial area, for example, now the GI lifespan from 14 years become only 10 years. For the high AZ, nothing happens, still remain 25 years in the world. If near the seaside, they find that the calculation result come out is only about 12 for the GI. For unconsidered, it's about 15 years based on calculation. So, in summary, for the part of the history itself, two family, English, also English family. So, from just now the case that I shared with you, the type AZ or English family will be much more durable compared to the type Z. Okay, next part we will talk about the ping performances, the ping durability. So from ping perspective, there are some important criteria that we need to be aware of. From here you can see that you start here. Performance against shocking, color detections, glow detection. This is very important. So from here you can see that the technology that we use in also, for example, is a small policy. Best overrated or very good overrated. We also have a product called Column SPD using a pre-layer ping system, which actually give you the much more superior performances. So in order for us to study how to qualify or quantify a product is good against color fading, one terms you need to be aware of is called delta E. This number. Delta E. Okay. This will measure how far or how high the color changes. Higher the number means much more color fading. From here you can see these are exposed sample, these are the exposed, and exposed after exposed. If I put up the delta E something, you can see a major differences between. What if I put up this sample? Delta E 21. Color you can see much more easy to be seen. And this part, we can put that some suppliers giving warranty for color fading, they may put in the delta E number very high. They put in the delta E maybe 30, 30, actually 2 minutes, 30 means actually quite color fading. So 4 minutes. So be careful. Okay. For me personally, anything below 20 delta E is still quite reasonable. Below this, more than this one is totally already already converge. Okay, this one number that we export, the technology used by Usco and also commitment to conventional product in the market. So from here you can see that this one have a lot of color changes. Yeah, from a really beautiful blue color, become a whitish rosary. Then this is a darker color, same thing, before and after. And then this technology used by us before and after. The color change is very minimal. And this actually exposed in our compound. You can see that this is our product before, after. This is what you can get in the market before and after. The line is really more than 20 units after 10 years old. And then this is a little sample that we get from Australia. This one compare with those premium quality level of products. On the images on my right, this is the two sample from competitor. And then here, this two is from Bristol. So from here, one of the unique findings is that our carbon product, which are using the cobalt, the total unique even much more lower than the PVDF in the market. Because PVDF, as I mentioned, is a very durable product. Yeah. But our polyester even can be done. This is 3.2, this is 2.8. You can see the chart change. Yeah. What if Bristol PVDF? This one, very low delta E. This one you cannot see any changes. So the formulation itself does do the wonder. And we are quite fortunate, the formula that we used for this product was all came from Australia. Okay, they do all their research, at the end they find the best treatment and also very stable product or pain in order for us to have a very lesser or low color fading rate. Okay, the next part, I want to share about the cartilage corrosion. This is very important because from this diagram itself, we can see that how come the PADR system will only give you good, means that slightly inferior compared to the polyester. We have the reason why this can happen. Based on our lab study, if I put a sample inside a corrosion test chamber, this is a PADR to the seal. So you can see every cartilage corrosion happening. All the layer already is preserving means corrosion that already happened. Compared to this number, using polyester system, there are no preserving sign observed on the sample. This means that the PADR system is not the best brand if you want to use it in a seaside or near any exclusive emission. And all this actually is a case study that shared to me from Australian colleagues. Because during the earlier days, they thought PADR is the best, so they just use it near the treatment. I'm sure some of you, some supplier will come to you also say the same thing. PADR can last very long, even though near the seaside. This statement to me is only true if your substrate is a non-ferrous aluminum. PADR is okay. PADR to the steel is not okay. You will get corrosion pattern. Likewise, if I'm using GI and 775 PADR, also get cartilage corrosion pattern, because it's like a corrosive site. And then this is actually shared to me by my Thailand counterparts. It's a powerhouse project. The client and don't listen to our advisor, because we filtered our use PADR quality. And this is what they get after 18 months. They actually get a complaint. So they share with me this follow us on Jack. Why this happened? And I told them, can you let me know what's the spec for the product that you use? PADR, they are not really sure the corroded. Because we all know from day one, you want to use PADR steel near the industrial area or heavy industrial process, prepare for a space corrosion happen. All the pain already is and these are our case study, 29 years old, on the polyester coated steel near the seaside. Okay. I went to the site and then I captured all the data. All the cartridges of this colorful steel is still very fine. No, nothing happened. Likewise, the rib edges as well. Everything does so good. No rusting happens. What if these products are really able to see? I'm sure that cartilage corrosion already happens. And the third part is about the By-Law. This is something I'm sure some of the members here already received a document from the Camp Central that the By-Law has been updated. One of the clauses that related to the wall heading, the By-Law from wall heading will be the clause 1 form. Okay, I brought this for all of you to see because this is too small. So from here itself, the magic number here is 18 meter, 1/8. If your wall heading installation, the building height is more than 18 meter, 1/8, you need to comply to PS 414. What if the wall heading height is less than 18 meter? Your wall heading need to comply to the Class O requirement. This one mentioned in the By-Law 144. Yeah. And what is the Class O? So Class O format is very simple. You need to set the sample to pass two testing. The BS4 part take and also the part 7. Once you pass these two testing methods, once you pass them, then you can qualify yourself as a Class O compliance or conformance material. Then A14 is a new test, it's a new testing scheme. This testing actually applies to the whole building system. Okay, they actually have a part 1 and part 2. Part 1 means installation on the necessary wall. Part 2 means installation with the super steel somehow. So it's not defined. A14, part 1, A14, part 2. Just be careful. if a product has passed the F1 part 1, doesn't mean that it can pass the F1 part 2 level 1. Okay, because we saw some manufacturer they want to play some tricks. So this is a lot and share. We play some tricks on this F1 form. So to me, be careful. Okay. And then this is a very simple conversion chart. This chart actually I made it based on what the formula shared with us. Okay. And class 4 itself, the final testing surfaces is only the C, the top surface. Let's say you have a PU method or visual method sent to the serial method. You need to check the fire test on scaling. Okay. Compared to F1 4 is a full scale testing methodology. The whole build-up will be subject to fire. And for this right here itself, you will see the fire will burn through everything. This one is only the surfaces. These are the first differences. Second difference is the way of fire we actually oriented. For the class 4 or class 6 up-down requirement, the fire is always horizontal, the source. Compared to F1 4 is always vertical. This vertical fire direction will create much more intensity to the sample. Means that if you can pass this one most likely will pass without any problem. Third one is that usages of combustible material. We also check for some product like PU panel or PU method, the instrument code is a PU code. But they always can show you the password set because the testing of the service you can pass. But what if you're going to use this product to more than 80 meter height? Then you will do the F1 form. That's it, may fail. That's why the OMA said that I don't care what you use for F1 form, if the result pass, I also allow you to use. But for the transfer itself, if your result pass, they will still allow you to use by providing the reading height is 80 meter. Okay. The last one to share is the detecting cost. The cost of the reading height is very, very high. Okay. F1 form is really possible to 38K. Minimum. This does not include the workmanship, installation cost, and the system cost. So if I did somebody, they're sharing about 70 to 80K to do one complete test. Compared to the past and past 7, add up everything less than 5K. You can do it. Yeah. Okay, now the third part is design part. Design sharing. First one is the industry area, KYE, UW. This one is really the client producing those absorber for the car and for the mobile. The client has been using our product since many years. The first phase of the factory was installed in 1997. This one. Nice. We come up to the roof, do some assessment to check the performance of the carbon series after 22 years old. So from here you can see that these three, even though supply in the different phases, now they actually coded back. This one is the oldest one, 22 years old. Nothing happened except for the black color stain that they entered from the chimney. So we come close a bit, everything is still in good conditions. From the aerial view, same thing. You only can see the black stain. Nothing happened. After 2 years, what they do is a very long time. And of course, as usual explanations, one of the reasons to determine whether product is still good or not good is the courageous performance. So from these images, after 2 years old, the courageous of this carbon still performing. Nothing happened. But one thing I want to share is that we do observe some sound motion happen on the rich capping part. You can see these images. These are trapping. Why it runs? Because of the contact with dissimilar method. In this case, the dissimilar method is copper tape. Copper, we all know that it's not young with steel. Because copper is a much more stable or passive material compared to steel. It's much active. Why you put these two materials together, you bound to have failure happen like this one. Failure happens. That's why we try to avoid using the copper tape, if possible, replace it with the aluminum tape. This is element 2. This one actually is a marine site. Normally for marine site, we recommend you to use carbon outcrop AZ200. So from here you can see that a different timeline of the project itself. 2004 was after 1 year installation. Okay. 2014 is 2004 is after 1 year. 2014 is after 10 years. Then 2020, 2022 was 19 years already. So from these 3 images, I feel very proud of our carbon steel performances because the blue color after so many years is still blue. Maybe they happen, but not fade until it become whitish. And the best part is that even though the project site was near to the sea, you can't see any subrouting happen except on this. And then these are up close, these are most bigger on the sea, the jetty. All the carbon steel roof, by the way, the roof is supplied by Kawa, and certified by Sanko. Sanko is a deep corridor profile. This profile, you know, installed in the seaside. We didn't observe any of this profile was actually detached off from the lead. Everything is still well intact. And then the images, and you can see, everything still looks very good. Nothing happened. Still looks good. Same thing, near the crushing area, and silent truck, you can see no nothing happened whatsoever on the country after 19 years. Of course, cooperative again, because we were able to find some area that gets of conducting fault. Upon checking investigations, we found that due to the copper tape problems. Last case study, the mask hanger A380. This one actually, I want to choose something that is very durable against the color plate. Of course, we recommend to use FPD, pre-decorative steel. So after 12 years, we went again to see this hanger. Everything still looks good. And we bring some sample to the site, compare before and after. So from this image itself, we can see that the before and after just like no differences. Very minimum changes happen. This is really about blue scope pre-DF product. The color was so stable. Nothing changed. How about the wall area? Same thing. We put side by side before and after. So you can see the color change is very minimum. Next door to this hanger itself, we found another small debate. Unfortunately, all the perimeter steel is already very corroded. Yeah. This one, you can see same environment. They are already corroded, but the roof is okay. Nothing happened. Okay. Next question is always people ask me, is all the other still the same behavior? I must actually don't like the or else you don't get some problem. Corrosion attack, iron color fading. The worst part is that the pin fell off. This also happened. First sharing is that this is a case whereby we receive a call from the developer, ask us to go to the site to do investigation because the developer claimed that the roofing sheet are using wood scope material. Okay, so we went to the site and conduct our investigations. Upon checking everything, we identified that they actually have a block A, B, C, D, and the center core. So all these 5 different locations. Upon checking the detail, we found that the client complaining actually is a center core, also the block C, the phase C location. Because the client said that they found nothing happened on the surfaces after 5 years old. Then we go and check. Roof B, roof A is still okay, nothing happened. But only happened on this center core, this one. So as usual, we go to the site. We also ask his daughter to come together so that they can have a moment under that. Why you want that? That's not they want to share one point about how to check the wearing text. So upon open up the lab, we found wearing text. But the wearing text is not a blue scope wearing text. It's by others. This is not ours. Then you also observe that the color performance is very poor. This is a sub-lab area. This is always the area that not going to expose to the sunlight. That's why the origin color is still preserved. So you can see that this is very beautiful blue. But after 5 years old, everything gone become garbage. So as usual, I mentioned, look for the wearing test, confirm whether it's blue scope material or otherwise. And then upon open up the other roof area, we found that our product area thing is still performing without any problem. Compared to PS, it's very very cold. And then this is to show you that what if I use a simple tools. The tool is several image from Google. This is a very good tools. This is how I can use the tool to check the condition, the latest condition. Upon checking in all images, the center cord itself already corroded badly. Likewise, the block C of everything just badly corroded. The block A, B, D, which is using our material, is still performing. No nothing happens. Yeah. So this is our so-called strong statement saying that not all the constituents are the same because they depend on the formula they use, the way they produce the material. Gazettement 2, same thing. The roof of this project itself, some portion was applied using our material carbon steel, some portion is not. The center portion here is a non-useful material. The color is already totally faded or gone from the initial green color, now it's a beige color. This is what we term as you buy one, you get another free, buy one free one, different color, and you get another color colors. And then also you get another bonus, it's corrosion sign already happened. You can see all the corrosion sign already happened. This only after 10 years old. Carbon steel on the curve here, everything for the curve group still perform. Then in year 15, the corrosion attack is even worse, become very coated. Of course, some building owner will try to do repairing by overcleaning the surface, but it won't help because the base is already very coated. What is the latest condition? I go back to Google Map and see. You can see after 22 years old, everything just concave. For that here, the one still is okay. You can't see any passing sign happen compared to this one. Okay, come to the discussion. See the very different chart. I want to share with all of you. By default, if any project, of course, we recommend you to discover one still. It's all the deep for the technology. Okay. What if your client wants to project? I want to have a bare finishing, no paint. Okay. Of course, they go with single steel, no problem. The worst part that I worry the most, what if near the seaside? Then for me, you better increase the thing class, become 8200, so that give you more durability performances. Okay. Then what if your client want to have a color finish and yet the clean performances must be at least 15 years to 20 years minimally? Then you can choose a color one. That's easy using 3-layer cleaning system. Okay, to give you much more color durability. And what if the body side is next to the seaside? Of course, using the color one or glass field. Okay, gazettement with polyester technology. We will not advise to use this one over here because seaside is very quality. You can attack a 3-layer acoustic. That's why I don't recommend. Okay, when it comes to different type of corrosion site itself, you also need to check the condition itself. For example, marine conditions. There are no type in Malaysia. Either the calm marine, like the images over here, calm marine, because of jetty, those very calm, or natural fish, this one. You can see the third condition. Okay, that will happen. Typically, this kind of condition will be much more higher possibility compared to the company. Then we come to the industry with the project. We need to check whether are there any corrosive industrial fault from a client operation or from a nearby building. Let's say God also not really careful because this kind of particles of water can reduce the lifespan of the material. And then this is the people chart based on the listen from marine references. Normally, we recommend anything that has 100 meter, better use carbon or steel, AC200 material. Yeah. Now, of course, if your site is near the deep of the better way to prolong the lifespan of steel is always do some maintenance. Using the water to hold some, those are unwashed area. What are the unwashed area? Area that cannot be washed away by the rainwater.
something as a watch area. And the last part is the root nodes. This is the typical root nodes that probably you can see from a side. So saying this is due to the connection, available solution, basically all the soft particles or the that eventually soft particles become very lasting and then cause corrosion happen. Second is that some installer or some other trades, whenever they want to do their works, they use the roof and the platform to do their work, and this actually can cause the material to being damaged by this. And when they see this one, they will panic. What do? They will buy the game to get all this don't thing happen. That's why if you find any sectors, don't worry, we can always contact the scope to set for devices, whether it's the data is still fit for usage or otherwise. We can provide with the kind of feedback. And the fourth, as I mentioned just earlier on, copper tape, place or white using copper tape. And number 5 is the partner, because some profile you need to use to make sure you submit the class 4 or class 3 partners. And flashing, this is also another part that we call it big tricky, because some projector they want to use your carbon steel or silicon steel. Flashing, they want to save the cost, they use other material. If they use this method, you may have some chances to get a similar performances. In this case, you can see the GI ranking is already very crowded compared to silicon steel. Because the best is to use both the flashing and the manual same kind of material to get a similar performances. And then BMT, just like I said already, make sure use enough BMT for the lab, or else they can get all these damages. Of course, for also we have a simple checklist that normally we will share back to customer or to anyone who want to know more about the components. This is a simple checklist from partner type to the costing, also to the production usages, and also the planning team. All these things to be aware of and clean and ensure that everything is confirmed, then the natural warranty will not be affected. Okay, summary. First, always spec in using BMT, and the minimum BMT for roof leach should be 0.42 mm. For wall bearing will be the 0.35. Next is at the bottom marking, the very next dimensions. If you form anything on the side, just flip over the deck to show me the durability of the material. Third point about the coating type, I'll just share already. The type AZ coating type will have a much more longer lifespan compared to the type Z. And then the coating class, how many grams, how many kilometers square. Higher coating class means much more durability. Example, Z150 will be better than Z100. Z275 will be better than the Z180. Then equipment product itself, the polyester system used by also personal for carbon steel, is already shown much more better performance compared to any other technology in the market. Then of course, next one is that please avoid using any PVDL coated steel if the polyester is marine or process environment. After I share a lot of people already using anything in PVDL in nature, still you can get pollution failure. This one proposal is always using polyester base, if possible, using 800. That's not true. Next point is the By-Law. This one, the By-Law 144 is already updated. Got 2 types already. Class O is for those buildings that are using less than 80 meters. 814 is for building height more than 80 meters. And always look for relevant suppliers so that you can get a show of those quality level. And the last point is the dual notes. Please follow all the dual notes that shared by the manufacturer. Example, don't use any component. Okay, so that's all for my straight today. Thanks.
Hello. Yeah. Maybe I'll just take over. I think that's the end of the sessions, right? We're gonna have a break, right? For 15, 20 minutes, maybe, right? There's the crowd here. Not enough sharing of the washroom. So 20 minutes break. What's the time now? Huh? Now it's 10:20, right? So we'll be back here at 10:40. All right. See you all back here at 10:40 and have a good break. Good.
Swissmar is Malaysia's leading roofing and cladding solutions provider. Over the years, it has grown leaps and bounds and firmly established Swissmar as a leading global supply and service provider. Through its relentless pursuit of technological innovations and advancements, Swissmar holds firm its steadfast commitment to providing total consumer satisfaction with effective service and customer care, offering everlasting returns on investments for all stakeholders. At Swissmar, we believe in materializing the world's structural visions with great integrity, employing the best of customized technology and manufacturing solutions which are fit for the communities of now and tomorrow. Thus, some of the most beautiful, long-lasting, iconic buildings across the Klang Valley carry our mark, including various infrastructure, industrial and commercial buildings, and upmarket residential units. At Swissmar, precision manufacturing is what we do best, and our work is also complemented by other services like architectural consultation, design engineering, research and development, and innovation to ensure we offer our best products and services to our customers. We received the Brand Laureate Award for 3 consecutive years and awards from one of Malaysia's largest Chinese dailies, Sinchu Daily.
We have to constantly adapt to the market needs, to what customer wants, and most importantly, we need to innovate.
Offering the best of steel as its raw material, BlueScope plays a key supporter in establishing Swissmar as a premier choice for the world's roofing and cladding solutions. Colorbond steel, made by BlueScope with proprietary Australian technology, is a true testament of time. Ultimate durability solution that meets international standards and performance expectation to ensure your iconic structures and its beauty are protected for a lifetime. At Swissmar, innovation lies at the heart of everything we do.
made by Australia.
Swissmar is Malaysia's leading roofing and cladding solutions provider. Over the years, it has grown leaps and bounds and firmly established Swissmar as a leading global supply and service provider. Through its relentless pursuit of technological innovations and advancements, Swissmar holds firm its steadfast commitment to providing total consumer satisfaction with effective service and customer care, offering everlasting returns on investments for all stakeholders. At Swissmar, we believe in materializing the world's structural visions with great integrity, employing the best of customized technology and manufacturing solutions which are fit for the communities of now and tomorrow. Thus, some of the most beautiful, long-lasting, iconic buildings across the Klang Valley carry our mark, including various infrastructure, industrial and commercial buildings, and upmarket residential units. At Swissmar, precision manufacturing is what we do best, and our work is also complemented by other services like architectural consultation, design engineering, research and development, and innovation to ensure we offer our best products and services to our customers. We received the Brand Laureate Award for 3 consecutive years and awards from one of Malaysia's largest Chinese dailies, Sinchu Daily.
We have to constantly adapt to the market needs, to what customer wants, and most importantly, we need to innovate.
Offering the best of steel as its raw material, BlueScope plays a key supporter in establishing Swissmar as a premier choice for the world's roofing and cladding solutions. Colorbond steel, made by BlueScope with proprietary Australian technology, is a true testament of time. Ultimate durability solution that meets international standards and performance expectation to ensure your iconic structures and its beauty are protected for a lifetime. At Swissmar, innovation lies at the heart of everything we do.
Colorbond, made by Australia.
Swissmar is Malaysia's leading roofing and cladding solutions provider. Over the years, it has grown leaps and bounds and firmly established Swissmar as a leading global supply and service provider. Through its relentless pursuit of technological innovations and advancements, Swissmar holds firm its steadfast commitment to providing total consumer satisfaction with effective service and customer care, offering everlasting returns on investments for all stakeholders. At Swissmar, we believe in materializing the world's structural visions with great integrity, employing the best of customized technology and manufacturing solutions which are fit for the communities of now and tomorrow. Thus, some of the most beautiful, long-lasting, iconic buildings across the Klang Valley carry our mark, including various infrastructure, industrial and commercial buildings, and upmarket residential units. At Swissmar, precision manufacturing is what we do best, and our work is also complemented by other services like architectural consultation, design engineering, research and development, and innovation to ensure we offer our best products and services to our customers. We received the Brand Laureate Award for 3 consecutive years and awards from one of Malaysia's largest Chinese dailies, Sinchu Daily.
We have to constantly adapt to the market needs, to what customer wants, and most importantly, we need to innovate.
Offering the best of steel as its raw material, BlueScope plays a key supporter in establishing Swissmar as a premier choice for the world's roofing and cladding solutions. Colorbond steel, made by BlueScope with proprietary Australian technology, is a true testament of time. Ultimate durability solution that meets international standards and performance expectation to ensure your iconic structures and its beauty are protected for a lifetime. At Swissmar, innovation lies at the heart of everything we do.
Colorbond, made by Australia.
Swissmar is Malaysia's leading roofing and cladding solutions provider. Over the years, it has grown leaps and bounds and firmly established Swissmar as a leading global supply and service provider. Through its relentless pursuit of technological innovations and advancements, Swissmar holds firm its steadfast commitment to providing total consumer satisfaction with effective service and customer care, offering everlasting returns on investments for all stakeholders. At Swissmar, we believe in materializing the world's structural visions with great integrity, employing the best of customized technology and manufacturing solutions which are fit for the communities of now and tomorrow. Thus, some of the most beautiful, long-lasting iconic buildings across the Klang Valley carry our mark, including various infrastructure, industrial and commercial buildings, and upmarket residential units. At Swissmar, precision manufacturing is what we do best, and our work is also complemented by other services like architectural consultation, design engineering, research and development, and innovation to ensure we offer our best products and services to our customers. We received the Brand Laureate Award for 3 consecutive years and awards from one of Malaysia's largest Chinese dailies, Sinchu Daily.
We have to constantly adapt to the market needs, to what customer wants, and most importantly, we need to innovate.
Offering the best of steel as its raw material, BlueScope plays a key supporter in establishing Swissmar as a premier choice for the world's roofing and cladding solutions. Colorbond steel, made by BlueScope with proprietary Australian technology, is a true testament of time. Ultimate durability solution that meets international standards and performance expectation to ensure your iconic structures and its beauty are protected for a lifetime. At Swissmar, innovation lies at the heart of everything we do.
Next slide. Okay, I'll be covering these topics for this morning. There are 6 topics here. I think it's better for me to move forward here. So, first is metal roof profile long length. Today I'll be focusing mainly on the industrial building, right? Although we do a lot of residential, I will not be covering those standing seam profile. Already very long topics here. Number 2 is the types of metal roofing. Spoke to the gentleman just now. How to have a nice ceiling appearance for metal roof.
And then acoustic roof system, how to customize roof to meet acoustic requirements. FM approved roof system, there are a lot of FDI projects in the Silicon that uses FM approved roof system. And I'd like to introduce our Swisma Ultra G NTS roof system, and also to share some other materials that is also on NTS. And lastly, customized wall cladding system for industrial building, and to round up what is here 8414 about. Okay, move on. Okay. First, method profile. Okay, for factory, industrial building, which is typically long length roof. I have many, but I will only pick up two most popular ones. This is the grip deck tree fence, which is very commonly known in the market as tape block profile. So they treat with grip with the pegang. Okay, pegang or what? So here we do a hydraulic calculation to show you why this kind of profile is suitable for long length. I don't think you will see the forms from afar. We have looked it up. So what we do here is, this is the hydraulic calculation in the system, using those many formula and all that. So here is a profile. Here's the rainfall intensity. Okay, how rainfall intensity is very important, right? If I want to do magic, I bring down the rainfall to 50, then it can go very long. But it is not going to work when the rainfall is high. So here I use a very high rainfall intensity, 450 millimeter per hour, and this rainfall intensity varies from location to location. And I use a high value. So that's the rainfall intensity, that's the profile. And here is the line of the roofing, right, from ridge to the eave. And here are all the inputs parameters. Here is the slope, the roof pitch. And then the system will generate the calculations and will tell you the result whether it's okay or not okay. So here I have extracted the essential columns. So here the line is 130 meter, 5 degree, roof okay. So as your roof pitch is lower, then your line has to be shorter, right? That's how it works. So at 2 degree, 85 meters. So you design 2 degrees at 800, then this profile is suitable, right? That's what it says, okay? And that's how it is. So can follow, right? So it's pretty straightforward. So 85 is already a very long line roof and 2 degree. So I have received inquiries for 1 degree. 1 degree, even 50 meters for this, not so advisable. But in general, anything 1 degree is not advisable, even within capacity, because you can have negative gradient if the structure is not well done. And most importantly, it can't self-clean, right? Because the flow of the water is very slow. The steeper it is, the better it's self-clean. The more it's self-clean, the longer your roof lasts, right? To wash away all the contaminants. So we have deeper profile, like this one. This is 98.5. This profile is now what we use, I mentioned in my introduction earlier, in those E&E projects. So again, this is same hydraulic calculations. I will go to the highlights. You can see the numbers really jump, right? So at 4 degree, even 410 meter length, serious 410, okay? 1 degree, 200 meter length, it can perform, but unless you have to, otherwise minimally 2, that's my recommendation. I know why there is 1 or 2, because you want to box up, right? But then you don't want the fascia to rise, all right? Or your metal wall to be too high. So you always try to keep it low, but don't despair. Go ahead with what you want to do. That is the solution. And example, this is factory here. This is actually Boston, right? This is 107-meter length, 107, still well within the limit. This is using the seam block profile. And here, because site constraints and all that, we actually bring the machines to the site to do the productions because you can't carry anything that long. So normally, most often is produced on ground, but here it's too long and no site access. So what happened is there's a platform built and the machine is placed there and rolls straight to the roof, like you can see here. Right, the machine is right there and produced straight here. Okay. There is a layer of already installed below. Later, I explain why. So you can see the top. This is we got a top steam roof being produced. And this seam block profile is excellent for weather tightness and for wind uplift. And the reason is how you secure the roof. This is the motorized steamer. Some so once you install, there's a motor to seam up the joints. So it's very tight to seam. The earlier one is clip, we just clip on. So this is very, very strong, right? This is the Japanese profile. In Japan, the typhoons are very serious. So in Japan, they use this kind of system. So this is an example of what I say. They roll on ground to see the scaffold platform cost. And this is a long line roof, right? This venture electronics factory after being produced. So the second one is metal roof system. Okay, typically there are two types of roof system. One is called a single skin, the other is double skin. So very straightforward as described. Single means one layer of roof, double means double roof, right? So you got the bottom layer and then you got an in-field of insulation and then end up with the top skin. So single roof, here, this is a typical traditional way of constructing metal roof. Right up till now, I would say right up to now, because we can't do that anymore. So previously, it's very straightforward, no issue. You just have your fall over, Berlin, put the rock roof, and then you install your roof. Okay. So why can't you do that now? Why you can't? Because now you have your UBBL compliance, right? The clause of the AA. Where it's mandatory to meet a new value of 0.4. So now because of this evolved from MS5 to 680 and now become mandatory, and BNAC was the first state to adopt very strictly. So here, just to give you a background, how do we work out the U value of the roof system? So here, the U is a thermal transmittance value. The lower the U, the better. 0.4 is your compliance requirement. So you get the 0.4 or less. That's your compliance requirement. And K value is actually thermal conductivity is a material property. You use rock wool, it has this K value. You use fiberglass, it has use other insulation. So you'll be extracted from the suppliers, manufacturers' data sheets. And R is thermal resistance. So R is affected directly proportionally by the thickness of the material you use. So it's thickness over K. Next, I show you calculations so that you have a broad understanding how to achieve U value. So here, I think, gentlemen, the back, you want to read, maybe not so good, or very good, excellent. Okay. So here is a table, simple, straightforward, more like Excel sheets calculation. You have students from outside, there is always a given value on your R, and then the inner side, 0.125. These are insignificant numbers, so you can see 85 mm thick rock coolant, 40 kg. So the thickness is the thickness of insulation, thicker the better, of course. So 85 is 0.085, right? Then the lambda value is the material property, lower the better, is 0.036. And then the thermal resistance is actually this divided by lambda. AR is the thickness divided by lambda, you get 2.36. So R the higher the better, right? So you add all that up, you get 2.566. And below 1 over R is your U, you get 0.39. So 2.50 is your magical number that you have to achieve, right? So that's how straightforward it is using mineral insulation. Okay, so I mentioned the earlier versions you can't comply. So how to comply? So here is single spinner, earlier version and this new version. You see the difference. So the difference is you have, for us, we recommend not chicken wire mesh, that is already out of time. All the chicken has grown and grown away. So we are recommending BRC mesh. And the reason we recommend that, even you can do without, the fall is strong enough to support. To me, after interacting with installers, this construction is quite tedious, and we want to provide some comfort of safety to the installers. So the BRC is strong, they secure it nicely. At least the roofers don't fall through when they trip it. Okay, so the netting serves that purpose. We highly recommend. Most of the time they do away because fall gets fine. So I guess add-on is for the workers' safety, nothing else. Alright. You think they can do wonder, no need, take that away. So you have your usual foil. So but to incorporate the 85 mm thick rock wood, you can buy 85 mm thick fiberglass rock wood. And actually 85 is not standard, it's 75. But I came to understand that they not customize because of the demand, right? But we would like to recommend to buy 100 mm thick or 2 layers of PVC and get it compressed down to 85. You know, seems like a waste, but nothing goes to waste. And it's by design. Why? Because we want the deck to have in contact or in compression to, you know, why is that important? Right? It doesn't add on to the performance of the U value, but a holistic solution to a system requires to dampen rain noise, right? So metal roof without insulation is it vibrates when it rains, hits certain resonance and can be quite noisy. So in the past you don't have issue because the wood is compressed. Now if your wood is separated from it, you are literally not having any noise damping. So it's good to have 100 compressed now. So how do we construct it to make this happen? So we have this called subgirds because this roof is no longer sitting or installed over the turbines. There's a lot of mistakes in project without this illustration. You be scrapping the QS or scrapping the BQ. They always independently list up these subgirds in the BQ and they do not price for it and become a big issue. I can tell you. Either it's a VO or somebody taking the blame. So you got to be very clear, you cannot just compress it. Even if you can, very clever, you lose your U value. Why? You need 85 mm depth of thickness, right? You compress to 75, your U value is 1. Okay? Even if you can, you cannot do it. So that is how it works. And I will take you through a very simplified step by step. So that U value as highlighted is derived mainly from the rod wool or fiberglass wool 2.36. So this is how you do it. You put your netting first, and I recommend to secure, the wire mesh, secure the mesh strongly so you can act as some catch. Although in principle it doesn't comply with all, but it is clearly a catch. Then you have your foil, then you construct your circuits. Later I will share other ways of constructing this circuit system, and you will decide which is the best way that you think you want to do it. So we have a top head come C channels, and then you infill the rod wool. This is 100 mm thick. This top head is 85. So what happens is when you put your top hook, you press the wool down, right? So it becomes 85. So the 85 mm thickness is achieved through this height. If you make it 85, you can't compress beyond that. Okay, so that's how you do it on a single skin roof system. Now, what is double skin? So double skin is essentially basically what was before, except now you have another layer of metal deck as your inner skin or your underliner. Okay. See the U value, the bottom layer metal deck does not contribute to the U value. Alright. So why do you use double skin? That's the thing that you should ask. It doesn't help to contribute. So let me share with you the system build-up. So it's a conventional first layer metal deck, and then you now put up your circuits, fill it up, then there you go. You want to add foil, or you can just go straight forward. And so what's the advantage of double skin? Two things. Later on, you will learn more. I don't want to disclose now. For now, double skin, when you look up, you see the deck. So that's like a ceiling finish. To answer the gentleman's question earlier. So you want to use sandwich panel because you want to see the fall, but you can achieve using this, right? And the sandwich panel has a constraint in the length, as you know. They cannot produce long length, a lot of length. To do this, you can still have your 100-meter roof on the top skin. Nothing stopping you, but you get your inner layer. Look up. You can have a color one if you want, so it's a thing. And this holds all your insulation above. There's no fallouts of the roof. The fall is function, the fiberglass or what can fall off, and it's not good for indoor air quality. So that is only one aspect. Next, later on, I share why it's a must in certain situation. So here, straightforward, it's using mass insulation, most effective, and to us, we highly recommend. But today, contractors are very innovative, always VE. Just why can you ask me to VE my own design? So we can design coming forth like this, okay? And I'm sharing. So they just play the technical aspect. So here, just to facilitate the understanding, I should have a cross section, then it'll be very clear, but I didn't do that. So here, it's a double skin load. You have your metal deck. What happened is, see, the foil lay over the circuit. The circuit is here, the foil is laid over the circuit, and then your wool is laid over your foil, like a conventional, right? Conventional, except that it's laid over the circuit. Then your top head is 100 mm height. So what happened is you got air gap of 50. This slide will get time. So this is how you lay the foil and then the wool compress. So at the center you might have a 50, and then you have an air gap, that's your underliner of mm. Because making use of air, free, right? Air insulates. This was a big challenge earlier because nobody can substantiate. But today, NGBC, I think you all know them. They have too much challenges. GBI points are issued new value using area. They don't know how to justify. So they done their R&D and came up with their own table. But this is not an NGBC table. This is a research done by Professor Yabra of US. He's one of the pioneer researchers in this kind of new value. And the thing is, you don't get a consistent 50 mm in this case, right? So you compromise the thickness. So to what level you use the thickness? So they have done their own research, and basically they come up with average thickness formula through some calculations, and they give you an R value of 1.1972 if you do that. Okay, so we adopt that value, and the N gap, this is the MGBC chart table. You can get it from MGBC. So here the slope here is this is a reflective low transmittivity foil that you use, and if you have a gap of 50 mm from this pitch, you get an R value of 1.124 or 1.12. So we put the area R value from here, plug it up, and we plug up the, like here, I loaded up 50 mm area, 1.124. And we put that into the calculations, 50 mm 40 compressor is 1.2. And then you have your refractive airspace, 1.12, you add up, bingo, just nice. So this is like a trick to it, all right? You can still achieve, I say, 1 layer of wood, bingo, perfect, cost saving, but you're going to add another layer of foil. So in principle, you say, I can't say it doesn't meet, it meets, but it all has to do with your construction method. Are you happy with this for construction? Right? But to me, this is a better system than the next one I'm going to share. So this is uncompressed wool with air gap. So how does this work? Now, as you can see, the fold is laid over the subject again, but the wool is laid on top of the underliner. It's not laid on top of the foil anymore. The foil is sitting pretty, floating, and waiting for the roof to sit over it. And so then you have an air gap between the top of the wool and the bottom of the foil, because this is a 100 mm height Z spacer, another version of the sublet. So again, the 50 mm 1.124 counts. We plug into the calculation, and so this is what you get. So you can see the 50 mm is 1.12, and no, reflective airspace 1.12, and the raw wool uncompressed is 1.389, and you get even better results. All right. So between this and the previous and the 2 layers, what is your choice? They all meet your value. This is the toughest decision. So for us, first choice, use the mass insulation. Budget first, either this or the previous. Right? Do you think this is the best? Because better performance compared to the previous? Well, technically, yes. But what is lacking in this system is the wool is sitting pretty on its own. The roof is not even touching the wool, it's arm's length 50 mm away. So it's like a roof that has got no insulation, am I right? So your rain noise. So unfortunately, this kind of system is proposed as BE and widely used in project huge warehouse, 30,000 meters square roof with this system. When it rains, I don't know. That's another story, right? So you have to think of a holistic solution. That's my advice. Okay, just to show, because now everyone wants PV, solar world now, right? Spoke about 4 football fields or solar farms you want to get to visit their battery. So this research project we did, and just to show you, all these home systems we're proposing is ready for installation. You have the clips there, and close up. These are all climate systems, right? So using grid tech roof, you have these accessories to climb on, no puncturing of the roof around your PV cells. So there's a sample, even for a rare system, right? You can easily incorporate into our grid tech system. So this different option of circuits, there's always many approaches. So this is using ZAC mixer, the ZAC. It's fine, except when the ZAC goes up to 100 mm height. It's quite unstable, you know, that's an option. So if the roofer says I can install it, no problem, fine. But if you take the risk that the roofer will do the job, well, okay. If not, this thing can topple, so your roof might not be flat, all right? So this is cost-efficient system, cost-efficient, right? Or you want to have a continuous top head. We have a mock-up there with a continuous top head, very stable. Okay, other dua kaki, definitely very stable. They want material like that. So this one, what happened is stable but expensive. Obviously, you got more material on the top head. So this is strong, but cost is higher. Then that's how we come in between. You have a top head come seat. Because you have a top head, your seat stable. You overcome the instability of the ZAC. Use less material as well. But labor, they have to do proper alignment, so you have to offset labor costs. So we have done many projects, even airport using this when we do it on our own contract basis. But out there, the options is open. We can't tell people you can't do this, you can't do that. Right? If they're confident, fine. So you now have awareness. If you want to have assurance, maybe you stick to the top head or minimally. But if you want strictly cheap option, this one. So I can't say that it doesn't work because I've seen projects done before. Okay, I move on. So this is the block, right? You can see the mock-up out there. It's very different. So again, we can have the 4-array system. Similarly, you can also have clamps to do your PV panels. Next, acoustic roof. Now, how to achieve design noise reduction? Like here it is the upper floor metal roof, right? This metal roof. It's raining, or maybe an airplane going to pass soon, right? Your wife going on holiday or your husband going on holiday. So STT value is the main assessment for the acoustic performance, because this one STT can help. So STC is sound transmission class. That's what it stands for. So the higher the STC, the better. So STC 45 is naturally better than 37. Now, so we have acoustic software. It's an art and science combination. Acoustic is not straightforward, like engineering calculation. They combine many considerations, and the software capture the best options to evaluate. So we have a software. So we input data and we come out the result. This one obviously is the STC50 system. So to give you an idea, right? Okay, this is enabling generate noise. So you measure noise level using decibel dB, all right? So here, let's say it's a 90 dB noise on the external. Then you have your roof without anything. The STC is 18. This is basically your STC value. This is 18. This is 90. So what happened is the STC 18 will cut away 18 decibel. Not exactly, but very close to that. So a 90 less 18, you get the internal 73. So you will hear a 73 decibel noise inside, very loud. Okay. Then let me play the sound effect for it. Okay, there's an audio for you to compare, right? Right. Okay, so your that's now if the as you hear what it is. Second one. Next one is right. Very. This is 7 months. Okay, so this will give you a view of what the STC is about. Okay, thank you. So here is a very good idea. You can have STC 18 like the one totally no treatment, right? STC 31 is basic treatment. 41 we call average, which is quite good already. Anything 53 and above, serious. Cinema roof, what do you think is the STC value? Anyone want to guess? Cinema. You don't want to hear, I forgot to take my battery in so that I will get spoiled the movie. You must not be able to hear the noise, right? So the STC has to be high. So minimally, cinema 55, some 60. Very high, okay? Just give an idea. Household, you don't want to be dead silent time, you can give you some noise. 37 will be a good STC value. Okay, so this is a conventional construction. You only get STC 24, which is a thing. Now, how to construct it to improve the STC? You need a double skin roof. The single skin will not perform. Like a partition wall, you put one layer of partition. 50 mm thick, you put many layers, but one layer. STC is very poor, you're just throwing away your money. But you take 2 layers of gel and have an area that outperforms your 50. Right? It needs a mass spring and a mass system. So that's how it works for a wall, and that's how it works for a roof as well. So you need to have double skin roof. Then you insert mineral wool, air gap, cement board. It's like making kueh lapis spaghetti until you achieve your STC. So this is cement board. You need dense material to cut off low frequency because very strict. But most of the time, people are just talking about basically, I just want to have a system not very much into blocking off frequencies, for example. Only cinema roofs, they do that. So here, the previous construction, double skin STC 36. Not bad, not bad. Then, if I add a layer of cement block 9 mm plate on top of this, see, it goes up to 45. So I increase the thickness, add more second bond thickness, FTC goes up, right? So in principle, construction of the system works around those principles. Okay. Next, FM approved system. I bring this up because you are very fortunate because FM approved system, I would say predominantly in this part of Malaysia, northern, Kulim, Penang, right? Why? Because these are usually FM approved system. It's a membrane roof. There's no metal roof, but say just a metal roof that is FM approved. We have FM approved metal deck, but not as the top scheme. So this is the FM approved. So it's tested. Before that, I assume you all know what is FM. Who doesn't know what is FM? Okay, so number. If you are involved in FDI projects like the Intel, Micron, or whatever, the first document you will get is this compliance and your building materials and the roof and whatever can comply. So I just share touch base so that you have an idea, right? So this is a method that we have called Series 32. And we have a requirement 38 that meets their requirement. They want a minimum 38. They also have a spacing 250 and not more. And so the thickness is 0.75 ASD, 0.42 because of the structural depth to support the system. So this profile is sent to US to FM laboratory to do testing as a system. So FM stands for factory mutual. It is an engineering company also selling insurance. So if you use FM approved product, meaning to say tested by them, they are confident. Mine is FM approved. Hailstone, whatever, wind speed, whatever, is being tested. Fire safe. So if you use the FM approved roof, it's very confident. Roof is very important, right? Because if the roof is disappeared over a storm, your whole production is gone, right? You're talking about millions and millions of output per day or even millions. So they give you discount if you use FM approved. That's why the American company, they buy insurance. You spend a bit more. This is a GPI, you invest cost, you get value. Here you got direct benefit on your annual insurance fees. So why not, right? So that's how it works. And this is the typical cross sections of a membrane system. You have your metal deck, which is a FM approved. You see, it's installed. If you notice, it's installed upside down, right? It's not functioning as a roof. The reason is they want this flat surface to support the insulation, right? The pointed rib is not good for support. It may flat, and they do not want this gap to be too far apart, right? So there's a lot of mistakes made. The FM deck, they install the normal way, and then what happened? Your insulation is going to sink to the down, right? It's supposed to support the membrane. The insulation rock wool they use is not a 40, 60 kg. It's a hard rock, 165 kg. You can stand on it. It's a high compressive strength. Then you have your membrane. So here we've done a project with Sika membrane roof. So there are two types of membrane, PVC by Sika. So it's a mechanically fixed system for all these industrial buildings. They use later I show you the accessories. They screw it down, and the screws go all the way down to the 0.75 mm deck punch through. After this, go to IKEA, visit the store, look up, and you see all the screws punching through. Then you know why. That's how they secure the membrane. Right? Nobody looks up, like go and look up, you see a long screw punching through, because this is how you secure the membrane. Okay. So it comes in few thicknesses depending on the warranty. This is the TPO, right? Usually text is TPO, but PVC is long history, 45 years. So it's a choice of material. These are the accessories. Okay. This is where you have long screws. You seldom see those screws so long, I can tell you. It's really long, right? It can be a 200 mm, 60 mm screws all the way down the scale. So they have accessories for this as well. For rest, walkway, you can laminate this overlay for those traffic below roof. And when I say it's mechanically fixed, you see screw holes, right? But they have an overlay to cover your screws, and this overlay is secured by hot air welding. So the good thing about my rainbow is hot air welded, right? So you can treat penetration very well. IKEA has got fantastic numbers, a lot of roof ventilation, and the roof is almost zero gradient. Metal roof is not a choice. You can't treat the penetration here. You just follow up hot air welding, like macam blue here. Okay, and like a tailor made. So that is the advantage and can give you certain air tightness. So in a project like this, they use this kind of system. Climate no gain. So much by event state. So that's give you some idea. That's all. I hope that little bit of knowledge will give you some understanding. So next, I move on to anti-acid. So industrial buildings, you have acidic kind of environment. Look at this. This is the rubber gloves factory. Used to be the shining star of the stock market and the GDP, but today they're losing money. Hopefully, they don't lose their underwear and the market turn around. They are really losing. So you can see this is commissioning local emissions of the acid. You can see the rest of the roof is still intact, and then it's my roof. Got a complaint. Why your roof ocho? I said ocho. Then I can see it's not ocho. It's bad. Big lobang. So then we found out that the commissioning part, they didn't divert, they just go straight to the roof. You see how serious is the attack. So this is another scenario of rubber gloves. Even the steel structure is on some of the roof is supporting the steel, honestly. But the steel is not galvanized, it's bad. So we've been involved in supplying this, and I would say no business because it doesn't matter. They keep ordering right out here or so. We will be a year or so. Good business, but until we tahan, then they look for solutions. So that time was the bad industry to go in. So we come up with a solution. We have Roscoe, right, jointly develop a solution because you need to have a roof that can perform, and we need to develop a system barrier to prevent the attack of the seeds. So this is a customized coating from Roscoe for that corrosive industries. So Jack here goes back to his lab and all that, come out with enhanced protection coating, and that alone won't last. Trust me, not the same Roscoe material is so good because the acid is too intense at that time. So here is we developed this is Swissma. We developed a Swissma SMHC foam barrier. So it's a barrier system because the acid fumes come from internal. Atas, no issue. Bawah, all the corrosion starts from below. So we have specially formulated cross-link closed cell PE foams developed by us with the manufacturer. that can resist chemical attack. You can pour acid on the foam, no reaction. Right? For chemical resistance, excellent temperature resistance. But rubber gloves inside is quite hot, the oven, right? And due to its slow cell properties, slow cell cannot absorb water. It won't absorb water. You can put inside, soak it in, it won't absorb. You can use for nitrogen and so it's highly hydrophobic, no condensation, right? And durable, does not disintegrate. If we visited a rubber plant, they got the normal fall and boom. Some of the fall, the aluminum start to disintegrate and fly off, fall. You know rubber gloves, they got dipping plant, tank and all that. So if they contaminated your latex tank, the whole thing has to go. So we can have 4 rounds. So this thing has no 4 rounds, and there's no fungus growth, and it's that's why it's important. It does not contaminate the air. Okay, so it's light and sturdy. They resist deformation because of the closed cells. The cross-link properties. You compress it, you release the pressure, it goes back to its original thickness. So then it's a fire retardant, VOC, CFC, termite resistant, and it's excellent insulator. So we use this product as an insulation and moisture-standing foam. Then from there, we laminate something that is suitable for this use. This is how it looks like, right? This is the color freshly developed. So it is developed jointly with Blue Scope. This is only system now, come with 8 years warranty as a system. There are 2 alternative so-called solutions in the market. One is the aluminum. Aluminum expensive. They use PVDF coated, but aluminum is okay lah, not steel. You can use PVDF. PVDF coated 0.9 mm thick aluminum. Imagine the cost, right? Very expensive. And on top of that, screw fix, not conceal fix. For that kind of system, the warranty they give is not 30 3 years. For that price, you pay for 3 years warranty. Here, 8 years. So we thought we keep jackpot. By the time it's out, 1 job, 2 job, after now rubber gloves, nobody is extending anymore. Right? We even supplied the expert, they wanted to venture into this, the whole factory not utilized. A lot of developers jumping the bandwagon, but for heat. This is very unfortunate. Hopefully it will come back. So yeah, it's a proprietary barrier roof system. It's quick and easy to install. I will just keep all the notes. So the advantage is if you are on tight budget, you can use a screw fix system. But if you want to have a better roof, use a clip system to clip that. Whereas the aluminum, they can't do clip lock type of roof system. You know why aluminum can't do that system? Because aluminum has a high thermal expansion. The clip system works based on clipping onto the bracket. So if it clips and if you expand, you release, what happens? Become tight. So aluminum can do clip system. That's why the solution is a screw fix. When you have screw fix, what happens? You got another problem, leaking. A roof must not leak, correct? Say what you like, anti-SC fiber, if it leaks, it's not a roof. Okay? It's a car that cannot be driven to roof piece. Okay, then you have to use a regular screw fix. Screw fix is a class 4 levels. Very important, a lot of project roof system, including hands, back extension, is not using the right screws. As an example, go to one room, take a peep over the window, you see the screw grasping like that. But it's not the right type of screws. And that is another classic example. Jack highlighted thickness not enough, aircon service standard, and faded color bond. I think. That's small cut at the back. So we can use the clip system. And the thing is, we have to overlap 150, and you've got to remove the overlap to prevent spillage through. And this is a project we supplied. We have supplied two major projects, one here, one in South Malacca. Malacca is reroofing, it's brand new. And this is what it looks like. Very nice, right? So you don't see a room floor, you see a very neat, nice beige color. And that is the barrier. Okay, so it applies to rubber gloves, also applies other kind of industries that use ethylene fumes in production. So here, because we've been asked, so aluminium was one player, and to be frank, I also supplied 0.9 PVDF coated aluminium using my profile for rubber gloves. You can't either join them because I can use any material except for steel. I'm loyal to so. That is aluminium. Okay. So guess what? Doesn't last. It doesn't last. Still, that's why they give it 2 years. That's it. Right? Then they say the buyback scheme and all that. Why do you want to think about selling? Should think about performing in the first place. So the cash is buyback at 65% value and all that. So the client falls for it and we supply. But it doesn't last. I had enough. I really had enough because the complaint is no joke. Right? So then there is another option to choose. Plastic roof. Plastic got no reaction against acid. This roof is very good at better than metal. So they say it's a perfect solution, right? It's a godsend solution. But PVC roof cannot do clear system, only screw fix, right? So here I've done the research, I've done a presentation or request of a customer, so I'm sharing with you what I researched from internet, from catalogs of the suppliers. So Penfast strength is very poor for UPVC or plastic roof, 41 versus even 550 for steel. So when your low tensile strength means your spending ability is not there. Okay, that's why the building support, even they say it can go up to 1.2, trust me, they should not even go beyond 1. It's like your skylights, right? If you spend too far, it's going to happen, right? Same. So the next thing is they claim theirs is high structural strength. But I don't see what structural strength contributing towards the roof system. Structural strength means very flexible. If the roof is flexible, is it a good point? It's not a good point. You step on it. It moves, right? But they claim, I can say here, they even have catalog showing falling, running over the profile, come back to original shape. People are very impressed by what they see. Once the contribution is actually a negative contribution, if it's so flexible, you can run over it and then it comes back. Then if you step on it, no pressure, it can also go down. You want the roof to go down or not? Because then your screws washer will be loosened every time you walk on the roof. So it's just a perception that because wow, I mean, I'm not trying to run down, that's how they advertise. And then I said, try to figure out, good structural strength, they are very rigid, very fast, but that's what we want, right? To prevent indentation so that the screw is secure, right? So that's how they promote the product. This is the biggest concrete thermal expansion. They are 5 times higher thermal expansion, right? If for the length 10 mm, 10 millimeter for steel, this is 50 millimeter no joke. Okay, 50 meters. So what happens? Screw with the thing expand contract, what's going to happen? It bends against the screw, right? So your holes get larger and larger and larger until it is. Same goes with aluminum. Aluminum you don't install using normal screws. Use a huge washer. Why? Because they know that the holes are large due to thermal extension. Sometimes they use a saddle capping and they encourage you to put a spot, like engineering extension joint, put a spot so that it slides. But how to construct a slot like that? So people just screw. So when your profile is very deep, it pushes the top up. But when the screw get ruptured, right? Ruptured. So these are the setback. And of course, they are a bit lighter depending on the thickness, but that difference will not help in sealing your steel structures anyway. So here, extracted analysis for building devices. Everyone can Google. Now, ChatGPT very useful. You can ask ChatGPT. They can tell you a lot of information. So here you say high thermal expansion, not recommended in hot, sunny climates. Thermal expansion can cause damage around glucose, which is a fact, right? Here, combustibility and melting point. Of course, steel, as you know, doesn't melt until it's 1005. UBBL melting point is about up to 180. They have additive to add on to put fire retardant, maybe for the tahan 300, 400. That's not real. Okay. So recycle content, because the company approached me and said that they use this because it's innovative, it's a green innovative product. So I was trying to figure out why is it so green? Why? So when you say green, the 3R only comes to mind, right? So first is recycled content. So they have zero recycled content in the production of the product. Because if they add recycled content, the performance drop. This is another way you want to see skylight or whatever made from plastic, got recycled content. Recycled content is not green. Recycled content is disaster. It's not going to last. It has to be virgin. They claim virgin resin, okay? And that's the only way to make a durable product. So they don't have recycled content. That's the beginning of the process. The first hour already gone. And this is shared by the same customer who told me. He said he just want to hear from me because he did his own test as well and see what happened. The site labs smile at you when you fall. Very friendly. They always smile. When it rains, it close. After raining, beginning to go out, you see, don't know what happened. Hot sunny day, smile. So because it's a characteristic of the material. So warranty, they give up to 10 years. Color fading, I don't know. Steel, as you know, Ultra G, 8 years. Okay. So for non-acidic environment, of course, the warranty for color bond is much higher, as shared by Jack. And the best part is they say they are green because they don't need insulation to achieve U value. 10 alone can achieve 0.4. I think that is absolute. I don't want to run down on competitor product or alternative product, but they do claim they don't need insulation. That's why one, so that the budget is good and people believe, right? Try submitting to MGBC for GBI, I'm sure you'll be short now. So toxicity, okay, UPVC plastic you burn these are toxic fumes. And now the next item of the line, steel easily recycled, aluminum easily recycled, but this UPVC always most likely end up in the buried in the landfill and it's not biodegradable. And why? Because recycling of UPVC is more polluting. So there is not much incentive except for specific use, right? I actually do research on Google, right? And then, So the UBBC is highly toxic. Only 3% base is recycled. So you can do your own research. So after life use is important. Then solar panel, because it hasn't got a strength, it can be installed, but you have to plant it onto the building, to the valley. In that way, you can plant your system, you cannot plan, you puncture your roof. Safety, this is one thing that I always think about safety. That's why I put the VR switch. So when you put up a roof, when it's new, it's very strong. So UPVC plastic, what degrades plastic? UV light. You put your plastic bottle up there, exposed to weather, after some time, I think you'll find that your snowman becomes brittle, right? Because this has got no UV stabilizer, right? They send UV by putting UV stabilizer. Once the coating wear off, it gets attacked, right? So that is science. So what happens is, when you install a string, everything is okay, right? Then some years later, you want to walk the roof. Metal roof, if you see roughly, this one no sign of telling that what condition it is. You can't tell. There's no rust. If it's brittle, you can't tell. Correct. So it becomes an issue for safety, as far as I'm concerned. And scrap value, I do not know. I cannot be too sure. Is there a collector to buy this UPVC scrap? I don't know. I do sell my scrap in production scrap, steel, aluminum, fetch pretty good price now, because when steel price was up, scrap price was up. We don't like to sell high scrap price because then steel price is gone up. Okay, so that sums up the anti-acid ecosystem. The last one is customized wall planning for industrial buildings. Okay, what triggers like overnight? I think now everybody is aware already with the PEM circular. I did share it with IEF and PEM earlier. I think that time the awareness was much less. So what triggers? Okay. No, read of this project, Grenfell Tower. This project triggers, and some other project I share later. So I want you to know when this fire incident in Grenfell happened, how serious it was. This is how the fire spread.
The blaze started in flat 16 on the 4th floor of the east elevation. It rapidly spread through the window. The first image of the flames taking hold outside flat 16 was taken at 1:09 a.m. It took just a few minutes for the fire to spread up 19 stories to the top of the building. While the fire was spreading upwards, it was also spreading horizontally at a tremendous rate, and in opposite directions, until all 4 elevations of the building were engulfed in flames. The flames met at levels 22 and 23 near the southeast corner of the building. In total, 98 flats were exposed to the flames. 72 people lost their lives in the tragedy.
So that was fantastic. Look, 72 lives lost. There are a lot of fire, but not many lives lost. There's a public inquiry. From then to now, still ongoing. The British are very thorough, to say it nicely. Still no conclusion, but we extracted Google Grenfell, you get a lot of data, YouTube, whatever. Just really extracted one. How rapidly the fire spreads is scary. And that building was refurbish, then only caught fire, right? Don't refurbish, no problem. When they refurbish, then I would say cannot right. They go and spend money and cari pasar because they use flammable stuff. In those climate, they use insulation, they use PIR, right? Polyisocyanated. You know what PIR is? It's a polystyrene kind of foam for packing, right? It's used widely in America and Western, especially America. Those E&E, some of this building or even here we use PIR, polyisocyanated. Sorry, short form PIR. It's very good insulation material, very low thermal conductance. So if you take 100 mm thick rock wool, they only need 60 thickness because of the high good conductivity. Conductance. So they use PIR insulation. They have a star that catches fire. So this house is very fast for fire spread outwards and naturally. Fire was caused by kitchen short circuit. The intensity of the heat broke through the window, right? Then it spreads outward naturally. And that's how serious the start cladding can contribute. So this is how it looks like after the fire put out. And this is an extract from, this is the president of the public inquiry, Sir Martin Moore Weeks. So extraction of one of his report that observes, it is clear that the use of combustible materials in the external wall of rental cover, principally in the form of ACM. ACM is aluminum composite metal, ACM grade string cladding, but also in the form of combustible insulation, like I said, they use PIR insulation because of the cold winter. What's the reason why the fire spread so quickly to the whole of the building? So that we identify the cause, right? Big debate going on there. Why? Government building insulation. So this is the extracted, they do a test. This is the 8414 test. They did a test for the same lighting used for the project. So see how the functions the binary. This is 841 that's actually wrong. Okay. So that is only the beginning of the test. The spray water not to put up and not spread the wall. We not put up a fire. Starting really underneath bamboo start. Okay. Right. Okay. You all might not know, but you go to KL Federal Highway, you pass through this building. The EPF building 5 years ago caught fire. Right? Why? They use this polyfoam again, the facade cladding combustible material, polyfoam. And what caused the fire? It was a welding spark. One spark, high intensity. Control. Right? 5 years ago, this happened, rental, then bombastic, then do something serious, right? So they implement PSA for then how it started. I did have a conversation with BG because later I shared again the first company to have our product tested when the lab was in the pre-seed state before launching, after launch, because of a project. To add on to that, I think your architect would have received circulars, right? Existing building combustible has to be removed within 3 years. That was a year ago. That was the directive from Bomba. I cited that, but I cannot share because it is not for public. Do you receive on the job? Right? There is a directive from Bomba saying existing building facade that is compatible has to be removed within 3 years. period, if you look back retrospectively, not from now 8414, retrospectively implemented, but I don't see action taken anywhere. And Boba cannot shout because this same EPR 5 years later caught fire again due to renovation stuff. So he really put them on soft ground to go and implement the enforcement. Very, very sad. Just recently, only caught fire again if you read the news. Okay, so then again, this kind of fire happens around the world, Germany. So this is in Australia. I want to share because there is a legal implication for you guys. La Crosse Tower in Australia, June 2017 state tax, but already unlike the British top investigator, this one concluded go to court, done deal very fast. So this is how the fire was spread very fast. So this is the effect of the magazines. Apartment tower residents of water agents and this suffered land fire. They went to the court because they owned the building. So what happened? Judge finds architect proportionally liable for the cross fires. Conclusion is all the consultants, fire engineer, architect, whatever they are the one paying for it. You know what caused the fire? It was a smoker, unextinguished secret box thrown into a bin, caught fire. That's how serious, right? Smoker punished, yes, 2% of the damage already bankrupt, 2%. The rest, architect, fire engineer, quantity survey in Australia. They put the bill, like that. Just to share the story, it was specified. I think I can leave the brand now. Because you can Google and you get it. And look for plus was specified. Plus supposed to be fire rated. Contractor pandai like Malaysia, no difference. Australia, Masari, some VE, submit another look upon that now. Architect, what you do? You sign, approve. Then found he didn't use Alcohol Plus as initially specified, he used a non-fire rated. So who to pay? Contractor then. He's a culprit. Economy. Because he got his approval through the contractual process. He's not supposed to be a consultant. You are the expert. You are the one to design the building. That message is very loud. Contractor change, get away. It's a true case in Australia. They Google ours. And it's Commonwealth country. We are Commonwealth country, so you can figure out what's going to happen. And if I ever pull out this case, go to the court, the lawyer has an easy job. Right? Okay. So we were the first to get the test done, and that's how I know the one started. Due to this project, dear City Convention Center, significantly more. This opening phase 2 extension and the phase 1 is about 1 kilometer long of commercial complex, cladded with some coal street deck, 0.42 mm, colorboard steel. It's a trapezoidal profile, roof is very economical for planning, but hey, looks good, right? It's very popular in Australia. So in other words, tak payahlah pakai $300 per square SCP and all that. So because this building is more than 80 meters, like Jack explains, you will have to do the test. I mean, we were all fighting architect, developer is here and land lease. Land lease are powerful Australian, right? They argue with the Kampung say no. Construction in progress will be permanent test. That's how serious. Still not compatible test. So we did 3 tests. This is part 1. Part 1 is no masonry wall. Then part 2 for masonry wall. Part 3 was masonry wall because the support is of different orientation. They want it tested. So this is a video of the test, no audio, not too much disturbance. See, after 30 minutes, the fire subsided, you see the flame went up to the height, right? So this is a sequence. After setup, is an 8-meter height set up to 2.4 here and 1.2 on the wing side. So they set the fire and we left there for an hour. Right, the first 15 minutes is the key point on the start time. I won't go into the detail. I do a lot of sharing. It's one whole sharing session by itself. This is an idea of what it's like. So this is before test. After that, you see even the thing is still quite intact. And yet it's the test. Right? Okay, go back. So there are criteria. 5 criteria for part 1 masonry wall, facade over masonry wall. For those without masonry wall, like factory, warehouse, building, it's part 2 of 6 criteria. So as long as you pass all these criteria, you pass. So it's not about combustibility of the material. It's not about glass O anymore. In a way, you can say that below 18 meter, class O. Above 18 meter, need not be class O, technically speaking. Why? This is the ceiling test ACP. See the pools of fire. No, why? Because the temperature at level 1, they call 2.5 meter of combustion chamber, recorded at 900, past 900 degrees Celsius. And aluminum melting point is, everyone knows, 650 degrees Celsius. So what happened? Melted away. Right? So in technical terms, it's combustible because it's melted away. See, this is the outcome. The wall is there, the cladding was nicely cladded. It's a bit what? Melted away. So you put UPVC there, like it also melted away. If they do pass, doesn't mean you fail. No? They put fire storm, they control temperature reading. Right? 650 degree reading at level 2. If you 600, if you do not meet, you pass. Fire flame does not come out, you pass. So it doesn't mean it has to be incombustible. Right? So this is the 841 for this period. Idea. If people say, like Jack says, they pass, which path? Right? If they say they pass, it will pass. Part 2, if you are single skin, you melted away, how to pass, I don't know. Because 6 criteria is the fire cannot penetrate through that sliding layer. And this here is not penetrating, it's a big hole. So you have to be aware what part of the test they pass. Okay, so that's the method there. And that's ACP. I'm not running down ACP, but this is how the actual test will look like. Okay, ACP is being passed with the system fire stop and order. Okay, coming to the end, quick sharing, feedback, for example, customize. Now, a lot of warehouse factories, including, say, Robert Bosch factory recently launched. We supply the project. It's a double skin wall cladding. Not just roof, wall, double skin. So just a roof, you want sandwich, wall, some people for sandwich. If you don't want sandwich, we do double skin, customize, right? Here, we flag the 2 layers from the outside of the borders. This is the borders, your C channels for your wall cladding support. So we fix the first layer of cladding, then we put the Z spacer through the borders, infill, and then you have the external skin. So you infill what you like to achieve whatever performance expectation. So this is another way. Another way is you clad on both sides of the support. The one you clad from external out, here you clad both sides. There are projects where you can't do this. I can tell you one project. If you are doing an ASRS scaffold system, you can't clap on both sides because once the scaffold up, you got no space for Skype or whatever to go in, especially for warehouse. So the first option will be your solution. Here, you can do is good because we cover your organs very neat from inside, right? So this is the feedback how it looks like. This is a regular factory, the one and Astara, another traffic cycle. This is the first biggest multi-story warehouse. And this is to show data horizontally, right? And we also have a sign profile where you can especially horizontally for this profile. So we got a German Mercedes car, they like this. And you can also have a nicer, I think you use cassettes collecting, like this kind of images horizontally or vertically. This is a factory. Okay, so summary for long line low pitch, you can use an OC block. If it's not too long, click there. Two types of loop systems, single key, double key, can customize to meet your value. And to customize better loop to meet a loop scheme. You need a double scheme, you cannot do single scheme, and you can add those components, air rule and cement board to increase the performance. FM approved system is FM approved liner, FM approved insulation, FM approved top scheme. Everything FM approved. Your 40 kg of wool can use FM. Actually, it's not possible. But can I use one? They didn't send to FM for testing, so it's not FM approved. Only 175. Yeah, that's strict, okay. So Sysma has an anti-FPO system called Sysma Ultra G, and shared some characteristics about UPVC, not trying to run down, but you got to be mindful of the characteristics. All right, this is the indication. So wall cladding, you all know, above 18 meters, you need to go to 414. And there are criteria, 5 or 6 criteria, depending on part 1 or part 2. Below 18 meters is class O, A476, part 6, part 7, in part. That's it, all right? Like I said, the very strict series of testing body is RASA, PERA, the test plan. So you ready the gap, you ready whatever, we retest. So that ends my presentation. Thank you very much.